right, guys, I'm going to get started. So I did give you guys a warm-up question to try just because what we're doing today, the difference of two squares and GCFs are going to play a huge role in what we're doing in today's factoring. So I just wanted to kind of give you this problem to kind of remind you of a few things. So number one, if you were asked to factor this expression completely means that none of your ending factors have any common factors in them. All right, so we would look for a GCF first because we always do. We always look for a GCF first. What does the 3x to the third and a 12x have in common? Well, they have a 3 in common, and they also have an x in common. And since it led with a negative, we're going to pull that negative out with the GCF. So I'm going to say that my GCF is negative 3x. All right, well then what expression is left when you pull a negative 3x out of everything? Well, negative 3x times what gets you back to a negative 3x to the third? An x squared. Negative 3x times what gets you back to a positive 12x? A minus 4. So now what we normally do is we bring our GCF down and we take our new expression and we try to factor it again. What's my mask? All right. Now remember, when you go to factor this doesn't look normal, right? It doesn't have the x squared, the x, and then the number. It looks small. You have to say to yourself, wait a minute, could this be the difference of two squares? Is this a square minus a square? And guys, it is. And when we go to factor the difference of two squares, they're always going to factor to those matching factors. So we know whatever we put in the first two spots has to multiply to x squared, but it also has to match. And what do we know always will do that? X and x. And then I know whatever numbers I put in the last two spots that have to multiply to negative 4, they have to be matching numbers. What are the only matching numbers that multiply to 4? 2 and 2. And then what signs do we always need to make sure that these numbers multiply to negative 4 and then our rainbows add up to those 0 x's that it has in the middle? We need 1 to be plus and we need 1 to be minus. And that's how the difference of two squares is always going to factor. They always factor to those matching parentheses, and then 1 gets a plus and 1 gets a minus. Guys, can I get a thumbs up if you feel okay? The GCF, the difference of two squares? Okay, good. All right, because we're going to see the last kind of factoring today, something called factor by grouping. And then we're finally done seeing all of the factoring techniques. And then tomorrow, and then probably even Monday, I'll just start reviewing a bunch of factoring problems with you, okay? All right, so let me bring our notes up. Where is it? Okay, so this is the last factoring technique that I have to teach you, and it's a technique called factor by grouping. But guys, you can only use it on certain kinds of expressions. And the reason we're doing it now is just to kind of bring all the factoring together, but you probably won't use this a lot until chapter 5. So let me just say this first. Remember why we're factoring. We're learning and reviewing all of these different factoring techniques because ultimately we want to be able to use them to go solve quadratic equations. Remember when we were graphing the parabolas and we couldn't find the x-intercepts because we didn't know how to solve a quadratic equation? We started all of this factoring to review a way that we'd be able to solve a quadratic equation. So today's expressions are not going to be quadratic expressions. They're going to be degree 3, but this is what we're going to have to do in the future to find a degree 3 equations x-intercepts, to start breaking down these higher degree equations. So while we are factoring and while we are learning to hopefully solve these quadratic equations, we're also going to learn how we're going to be able to break down a higher degree equation as well. All right, so remember, if you are factor by grouping, you're still trying to break something up into pieces that multiply. To factor by grouping, a few things have to happen. Number one, the expression is not going to look like your ax squared, your plus bx, your plus c. The expression is actually very big. The expression must have at least 4 and an even number of terms. So guys, this factoring method only works when the expression has 4 terms or 6 terms or 8 terms or 10 terms. There has to be at least 4 pieces in the expression, and then after 4, there has to be an even number of pieces. So you can't do this with a 5-term expression. You can't do this with a 7-term expression. It's got to be at least 4 terms, or if not, 6, 8, 10, and so on. It also means you can't do it with an expression that has 2 terms or 3 terms. All right, also, you do want the expression to be written in descending order when you go to factor it by grouping. And descending order means you just want that highest power term at the front, and then it's going to work its way all the way down to the just number. So it would go from an x to the third to an x squared to a just x to a just number. All right? And then, in the end, you must be left with a common factor in order for factor by grouping to have worked. If you do not end up with this common factor, and you'll see what I mean in a second, it means factor by grouping didn't work, and maybe it's not factorable at all. And that's fine. I'm not going to assign you any like that, but just know in the future, this is not a foolproof method. Not everything can be factored by grouping, but it's definitely a technique that we are going to use a lot on a lot of problems that can. All right. Then I've given you a list of steps to follow. In case you get lost and you want to look back at something, I've literally given you a list of steps to follow as to how you're going to factor by grouping. If I read them off right now, it's going to sound like I'm speaking another language. So let's go to the first example, and we'll use them as we go through the first example. So guys, if you take a quick peek, look at these expressions that we're asked to factor. They're much bigger than our quadratic expressions that we're used to seeing, our ax squareds, our bx's, and our c's. These are much bigger expressions, all right? All right, so here's number 1. Let me get the list of steps so I can read it off. Step 1 says, make sure it's written in the correct order. So guys, you want it to go in descending order. Highest exponent all the way down to the constant, the just number. So 3y to the third, then your y squared, then your just y, then your just number. This is in descending order. It's beautiful. All right. Then, like always, with any kind of factoring, you're always going to look for an overall GCF first. Do these 4 pieces have anything in common? Well, guys, I'd love to say they have a 3 in common, but that ruined it right there because he doesn't have a number in front that's divisible by 3. I'd love to say they have a y in common, but he doesn't have a y. So they do not have an overall GCF. So that means we are ready to start factoring this by grouping. So to factor something by grouping, to get started, you got to make groups. So what you're going to do is you're going to group the first 2 pieces as an individual group, and then you're going to group the last 2 pieces. And this is why you have to have an even number of terms. You have to have the same number of terms in each group. Okay. So then in step 4 it says, factor out an individual GCF from each group. So guys, you're going to look at each group separately. First look at this group, then you're going to look at this group, all right? Treat them separate right now. So I want to find an individual GCF between these 2 pieces only. So forget about this. What does a 3y to the third and a y squared have in common? What is their GCF? Well, I hope you're saying to yourself that it's a 1y squared. That's what these 2 pieces have in common. So now you're going to factor that GCF out of these 2 pieces. So if you do that, what's left? Y squared times what gets you back to 3y to the third? A 3y. Y squared times what gets you back to a negative y squared? A negative 1. Okay. So we've taken an individual GCF out of the first group. Now you're going to go to the second group. When you go to the second group, you have to pull out the leading sign. So if the second group starts with a negative, you have to pull that sign out. Now, I want you to find the individual GCF of these 2 pieces. What does a 9y and a 3 have in common? Well, they have a 3. So let's pull out that positive 3. And now what's left? Positive 3 times what gets you back to a positive 9y? A 3y. Positive 3 times what gets you back to negative 3? A negative 1. And now, guys, believe it or not, you are done factor by grouping. And it worked because, look, you have to have that common factor I said. Well, guys, the expression that is left in each parenthesis matches. This expression has to match. If it didn't match, then factor by grouping did not work. All right, but since it matched, you've basically created a common factor for this term and this term. So now all you have to do is write your factors. What are your final answers? Well, guys, one factor is always going to be the one that matched. So take the one that matched and write it as one of your factors. That's one of your answers. Well, what you're essentially doing is you're factoring out this factor, and then it's going to leave you with, what did you factor out? A y squared and a plus 3. So whatever you factored out will make up the second factor. And I factored out a y squared and a positive 3. So guys, I know it's a little bit different and a little bit maybe weird in the beginning, but you're literally manipulating the problem to create these common factors that you're able to pull out of the overall problem. So that's how we factor by grouping. Now, if it had an overall GCF that we took out in the beginning, make sure that comes down to be part of your answer. And then you're always going to be left with this linear expression, this degree 1 expression, and then this quadratic, this degree 2 expression. Guys, your quadratic expression on your list of steps literally says, make sure you check that this is not the difference of two squares. Every now and again, the quadratic expression you are left with will be the difference of two squares. And then you have to factor it again to make sure that it is factored completely, because they have asked us to factor everything completely. But guys, lucky for us, y squared plus 3 is not the difference of two squares, and you're done. These will multiply to equal the original expression. So you have broken it up into pieces that multiply. So guys, if that's a little like, wait a minute, that's a little weird. I get it. We just need to practice it to kind of get these steps kind of like a routine for us. Can I get a thumbs up if you're kind of okay? Is everybody all right so far following? All right. So again, let's just keep practicing. Let's look at example 2. If we have to factor this expression by grouping, again, your normal rainbow type of factoring should not even be in your mind, because guys, look how big this expression is, right? I shouldn't even be thinking to factor it like that. So let's see, since it has 4 terms, if factor by grouping is going to work. Well, we would look for an overall GCF first, and I would definitely want to make sure that it's written in the correct order, and it's in the right order, and there's no GCF. So we are ready to factor this by grouping. So let's make our groups. We're going to group the first 2. We're going to group the second 2. So looking at this group only, I'm looking for a GCF between 2x to the third and 3x squared. What does a 2x to the third and a 3x squared have in common? An x squared. So take it out and show me what's left. X squared times what gets you back to a 2x to the third? A 2x. X squared times what gets you back to negative 3x squared? A negative 3. Now, we know, after the first example, that whatever is written in these parentheses, it better match what's written in the next parenthesis as well. So you can use this to kind of guide you, but don't force anything. All right, now we go to the next group. The next group, you have to pull out its leading sign. So I have to pull out a negative. And then what's the GCF between a 50x and a 75? What's the biggest number that would divide evenly into those two numbers? And it's 25. So 25 is its greatest common factor. All right, and then what's left? Negative 25 times what gets you back to negative 50x, a 2x. And see how they're starting to match? I'm starting to end up with that matching factor. All right, negative 25 times what gets me back to positive 75, a minus 3. And you see how you ended up with that matching factor, that matching expression? That means factor by grouping worked. So now let's write our factors. One factor is always the factor that matched. And then the other factor always is made up of, well, if I took the matching factor out, what would be left? X squared minus 25. Your second factor always comes from what you factored out. And then you can be like, okay, that's not bad. Well, let's remember, your linear expression should be done. Your quadratic expression, guys, it could be the difference of two squares, and it might factor again. Guys, is this the difference of two squares? Is this a square subtract a square? And it is. So that means we have to factor it again. Otherwise, we will not be factored completely, and it'll mark us wrong. So let's bring this factor down. let's take our quadratic factor and let's try to factor him into two more pieces. So guys, when we factor the difference of two squares, we know our factors have to match. Whatever I put here and here to multiply to x squared has to match and has to multiply to x squared. What do we know that does that? X and x. I know whatever numbers I put here and here to multiply to that negative 25, they have to match. So what numbers match that multiply to 25? A 5 and a 5. And then what signs do I always need to multiply to that negative 25, and then my rainbows get me those 0 x's in the middle? I need a plus and a minus. And now you're done. Now you have factored that expression completely. So sometimes they'll end with 2 factors, and sometimes they'll end with 3 factors. All right, give me a thumbs up. How did that one feel, guys? Everybody okay? Everybody hanging in? Again, the more you do it, and again, some students like this because it's kind of like, oh, thank God, I don't got to work the rainbows anymore. No, the rainbows don't come into play here. So this is kind of like a nice little breath of fresh air that we're not working those rainbows every 5 seconds. All right, let's try this one. I'm trying to show you a little bit of something new in each example. So guys, look at this one. We'd look to see if it's written in the right order. X to the third, x squared, just x, constant, just number. We're good. The order is perfect. All right, do I have an overall GCF? Well, what does an 8x to the third, a 12x squared, a 2x, and a 3 have in common? Nothing. They don't have a GCF, so that means we're allowed to factor it just the way it looks. So let's make our groups. Let's group the first two, and let's group the second two. And now one at a time, let's find the group's individual GCFs. So what is an individual GCF between these two pieces? What does an 8x to the third and a 12x squared have in common? They have a 4 and they have a x squared. All right, well, what would be left if I pulled a 4x squared out of these two pieces? 4x squared times what gets you 8x to the third? 2x. 4x squared times what gets you a positive 12x squared? Plus 3. So again, once you see this, you kind of know what you're shooting for in the other parenthesis, but don't force it if it's not meant to happen. All right, then we go to the next group, right? We know we have to pull out the next group's leading sign. So I have to pull out that negative sign. And now, what does a 2x and a 3 have in common? What is their GCF? And if you're thinking nothing, you're kind of right. They don't have a GCF, right? But guys, you're not allowed to leave this blank. You have to write something there. You can't just write a minus sign. So think about it. What's a GCF to everything in this world? What's one number that divides evenly into everything in this world? A 1. So when we say there's no GCF, there isn't, but that means a 1 would work. So we at least have to pull out a negative 1 because we're not allowed to leave that middle blank. Otherwise, we won't be able to create that second factor. All right, so now what's left? If I pull a negative 1 out. Negative 1 times what gets you back to a negative 2x? A positive 2x, so we're starting to match. Negative 1 times what gets you back to that negative 3? A positive 3. And guys, it matched. So that means factor by grouping worked. We did it, right? So now let's write our final factors. Our factors are going to be, one of them is always the factor that matched, 2x plus 3. The other factor we get from, what if I took that common factor out, what would be left? 4x squared minus 1. Okay, and then again, you want to double check that your quadratic factor is not the difference of two squares, because if it is, I can factor it again. And guys, is this a square minus a square? It is. 4x squared is a square, and 1 is a square. He's 1 squared. He's 1 times 1. He's a square. So guys, we're actually able to factor that again. So bring down your 2x plus 3, and let's factor our quadratic, our difference of two squares one time. So guys, remember, I know they have to match. So whatever I put here and here to multiply to 4x squared has to match. And who's going to do that? A 2x and a 2x. Again, we know it's not a 4x and a 1x because that wouldn't match. It has to match when it's the difference of two squares. All right, whatever numbers I put here and here have to multiply to that negative 1, and they have to match. And what are the only matching numbers that multiply to 1? A 1 and a 1. And then what signs do we need to multiply to that negative 1? I need a positive and a negative, and then my rainbows will definitely get me those 0 x's that I have in the middle. So this is your final answer, your final factors. All right, guys, how we feeling? Everybody hanging in? Everybody doing good? Okay, all right, I'm gonna do one more with you. I'm not even gonna worry about 5. We'll do that one maybe tomorrow as a warm up. Let's look at this one. This one brings everything possible into play. Number 1, it's written in a terrible order. This is not in descending order. I should have my highest exponent in the front all the way down to my just number at the end. So let's rearrange and put everything in a better order. So my 6x to the third should be first. My negative 8x squared should be next. My positive 24x should be there. And then my negative 32 should be at the end. That is descending order. Okay. Well, guys, like always, you're supposed to look for a GCF right off the bat. And we've been looking, but none of them have had it. Guys, look, an overall GCF for the entire problem. What does a 6x to the third, an 8x squared, a 24x, and a 32 have in common? Well, guys, remember, it's either 6, the littlest number here, or something even smaller. 6 doesn't divide evenly into all these numbers, so it ain't 6. What's the biggest number smaller than 6 that will divide evenly into everything here? 2. This problem has a beginning GCF. So we want to take it out. We always take GCFs out in the beginning if it has one. Otherwise, when we get to the end, we might not be factored completely. So let's take the 2 out right now. What would be left? So we're not even grouping yet. We're just taking out a GCF. All right, so 2 times what gets you back to 6x to the third? A 3x to the third. A 2 times what gets you back to negative 8x squared? A negative 4x squared. All right, 2 times what gets you back to 24x? A 12x. And 2 times what gets you back to negative 32? Negative 16. Okay, so now this 2 that we have pulled out, guys, just bring it down. We know he's going to be part of our final answer. Is that still on camera? Yeah. Okay. Now, you have to take the expression that you are left with, and now you want to try to factor this by grouping. So it's going to hurt our eyes a little bit. So try to ignore this 2 for now, and just picture this new expression as what we're trying to factor by grouping. All right, so let's group the first 2. I wish I had a different color for this, but I don't think I do. What do we have, red?
With green too. That's easier.
Ooh, green.
Mm-hmm.
Thanks. All right, so we're going to group the first 2, and we're going to group the second 2. So again, just ignore this 2. We're looking for this individual GCF. What does a 3x to the third and a 4x squared have in common? An x squared. Take it out. And then what would be left? X squared times what gets you a 3x to the third? A 3x. X squared times what gets you back to the negative 4x squared? A negative 4. All right, so now we know what we're shooting for in the next expression, but we're not going to force anything. All right, go here. We're definitely going to pull out the leading sign. And now what does a 12x and a 16 have in common? They have a 4. So now positive 4 times what gets you back to the 12x? A 3x. So we're starting to match. Positive 4 times what gets you back to a negative 16? A negative 4. So guys, it worked. So now let's write our final factors. So our final factors are going to be, first, we have our GCF that we took out in the beginning. He's got to be part of our answer. Our next factor will be the factor that matched, 3x minus 4. And then our last factor will be, if I took the 3x minus 4s out, what's left? X squared plus 4. And then we would check to see if that quadratic expression is factorable again. But guys, that is a square plus a square. It only factors if it's a square minus a square. The sum of 2 squares don't factor. So this is done. This is completely finished and everything's factored completely. So it can definitely get a little confusing when you have that GCF coming out first. Just try to ignore it and make it part of your final answer. Does that make sense? Is everybody okay with that? All right. Otherwise, if you were to leave the 2 in, it would still factor by grouping, but one of your final factors would have a GCF in it, and then you'd have to factor it out at the end. So I'm trying to avoid you guys doing that so that you don't forget to factor it out at the end. We always get used to factoring it out in the beginning. All right. All right, well, guys, I did create an exit ticket. It's one question on factor by grouping just to see how you guys are feeling. And again, I promise I won't give these exit tickets every day, but try the exit ticket. And then again, I asked you to rate yourself on a scale of 1 to 10 how you feel about your grouping problems from today. How did today feel? Good, bad, 1 being bad, 10 being good. All right. And then there is a homework assignment on Delta Math on grouping. I think it's 8 questions. All right. And that'll be due tomorrow. And now, guys, we've seen it. We've seen all our factoring skills. Okay.